Welcome to another episode on my Raspberry Pi 1 running Raspberry Linux, and in this case programmed in C, NCC. The Raspberry Pi is connected serially to a Minicom terminal, serial terminal, also using network cable to VNC, virtual network computing, and band cable to this breadboard, and some electronics. And the electronics are well, a lot of wires, some actual electronics like pot meter, not for this project, but some LEDs and some resistors, as well as wires and jump wires. And all of this to get a protocol for I2C working. And last time I made some progress by concluding that the demo that I'm using and doesn't work so far had a setting that I had completely missed. Also, 2 episodes ago I found that I had to use raspi-config, configuration file of the Raspberry Pi, to enable I2C. But not only that, it also turned out that last time I had to redo it for some reason, I don't know why, and then suddenly it did work. Well, the test worked, the program didn't. So on the internet there are examples, of course. Using those examples is not completely successful, but well, configuring the Raspberry Pi, I should say, is a clear example that the Raspberry Pi is not an ordinary computer, but it is a nice device. And then when everything in as drivers is loaded and the program doesn't work, well, why is that the case? So let's run the program again and see if it suddenly chooses to work. I have my doubts, kind of. So starting the program, and while I get screen output I should say, it's clearly that this doesn't work, and this is I2C. This is another project using SPI. Anyway, this doesn't work. So let's go to the VNC and see if I get things to work. Of course, this is for the oscilloscope to see if signals are working anyway. So here we are with the Minicom serial terminal directly connected to Raspberry Pi. Monitor oscilloscope set to detect I2C signals. I hope the time base is set correctly, but we'll soon find out. Of course, the GPIO, band cable to GPIO, probes, software, and this is something that, oops, it will work, but this is nicer. Last time I found out that I had to set this line correctly, because I am using channel 1 instead of channel 0, or device 1, I had to set this to 1 instead of 0. However, the problem is still that it didn't work last time. So first I'm going to show or check more appropriately that this one is working. Oh, the time base is very short set, so yep, that's better. A little bit shorter. Yeah, it kind of works. So, and this doesn't work at all. So back to square one again. Now last time, let me go into here, because this has kind of the same files that are over here, so that should be working. FD channel is now correct. I2C 1. One thing, by the way, that I should show is that here I don't have any sign that it works. It comes out with all blanks. And last time and the time before that, it had on 2 0 0, so 2 0 and 0 makes displays. It had a very clear 0 0 spot to indicate that it worked. Not so now. So how to go on? Alright, another thing that I should check is the header file, if there's anything in it at all what is of important, and I can't find anything about it, so I'm afraid that's a no-go. But alright, this is the header file that tells me nothing. This is the demo, which is this one, and it calls it somehow, because I didn't change it. Program, well, yeah, I obviously changed the program because the counting of the LEDs didn't make sense to me. Increasing the delay, and for the rest MCP right. Well, that's obviously a function from the header file, but apart from that, and apart from the fact that I have added screen output, this, something is not quite right. Alright, let's check this one. And it says is FD is smaller than 0. Oh, that is a nice one. Wait a second. Let me open a new window. This one is, come on. No, this. And then I want to look at, no, come on. This one. Because here the FD is equal to I2C initialization device I2C I2C minus 1. This is interesting. Wait a second. Is that device there anyway? Oh yes, it is. That's a relief. Right. So let's go in here again. No, I planned to look at this one. So this is exactly the same, and here FD is I2C underscore init. But there's nothing there that I can change, I think. FD address. So select, and this is select device. So where does it go at FD? Because the FD is this one, and it's being included here as well. So that's interesting. Device name, and the device name is this. I2C slave, yeah, right. Smaller than 0, no, it is not smaller than 0, it's more greater than 0, it's 1. So here it gets all its functionality. Nothing to be put in here, so let's look at the header file. And nothing to be seen here either. I'm not going to change anything anymore here. Should I change anything here? I doubt it, because this one is using FD, and the only way, although this is a different function from than this, FD is only assigned here, not here. So it raises a question. Set pin values, does this FD work? Well, yes, actually, because FD is a global variable, so valid in the whole of the program, and only set here. So I have to assume that it works. The question is, does it? Well, so far my conclusion is a big negative. So going back to the test, and I have to yeah, everything is in the right voltage. See? It does work. And by the way, this is clock, this is data. So yes, it works. Although I don't see here anything, but I've already told you that. So let's go. Well, now I have here the whole thing open. Let's use this one. So if this one works and this one doesn't, something isn't right. It's not right at all. So what about I2C detect? Does it have an instruction file? Yes, it does. Detect I2C chips. Oh, that's nice. And this program can confuse your I2C bus. Why? I2C detect -L. Oh, that's interesting. Oh no, now let's keep this open. -L. Now what is what? That's a nice one. Interpreting the output. See? Oh, this is interesting. The address was probed but no chip answered. And this probing was skipped. An address number in hexadecimal. A chip was found at this address. So, no chip answered. Ah. So how come when I use this one, did I see something here? Oh, wait a moment. This is probing on the input. Now it gets funny. Okay. Time to do something else. I2C config setup for I2C again. Because this is giving an input or giving a result that this doesn't work or won't work. Only if I get something in here, this has a chance to work. So, time to do raspi-config again. Advanced options. I2C. Yes, I do. Thank you. To be loaded by default. Yes. Okay. So. What about now? Well, this result maybe is just very clear. So this basically indicates that I will have to do raspi-config each time again, because it becomes clear now that the settings are somehow forgotten. Now it works. Does this automatically mean that this works? Not really. Not really. So, once again, does this work? Yes. So where to go from here? I can check the original schematics on this one. Let me grab, by the way, this, where I have all my schematics, and that is in this case this one. Alright. So in the original example, these had all a value, a certain value, and when I look here, they have different values. There are 6 resistors and 2 of them have a different value than the other 4. So it may be necessary to check on the value. Yeah, let's do that. Because this is a clear sign that it is working, but why this doesn't work? It's electronics. Alright. Right. I have thought about this program. Did I do something wrong? Did I do something right? This is the original program. The variables are the same, except that I have added here 0 because the print screen started with a normal number. They say 200 is a small delay. I changed it into 300. However, is that alright? Some suggestions say, alright, make it even a smaller number. I can do that. So I'll make it 30 instead of 300. How short that will be exactly, I don't know. Some also say, well, you should not use a shift command. 1 shift left I. I don't know. Could be. Let's first try this one. So make all, and first do the detect, then run the program. Still doesn't do anything. Oh, and by the way, I also tried to check if this is, well, this features the same stuff, but these resistors have a bigger value than the resistors I use. So that certainly should work if those resistors are actually being used. This doesn't work either. So one of the things that I can do still is follow one of those suggestions and do this. So this would then be this idea, and this would then be this idea. Will this work? I have no clue, but at least now I know what the original thing was. So let's make and let's run. And still absolutely nothing, although when I quit this, what does happen? Except that it says all data. Why does it say all data? So the control is fine. It detects a chip. Assuming that the LEDs used are still fine. I have to assume that. Question is, do I assume correctly? That's a whole different question, of course. These wires are all connected to mass, ground. Oh, how nice is this? Well, like I said, it should matter, should not matter. Let me keep these wires like this. Try again. Okay, this is better. It was touching the wire to the probe. Now it's not. That's a difference. And this one should not touch potmeter. So what's up? Really? Well, of course I can use just another LED, and let's see what is actually ground in this one. This is ground. This isn't doing anything, so I might try my luck here. If the and this is pretty hard to do. Let me use pliers, maybe that works. And I'm not covering the LED with my hand as well. So let's try this. Nope, nothing. Alright, let's change it back and try again. You never know what you screw up when you're doing. So this goes out, and this one goes out again. So one more compilation into the old idea. And another test to see if this LED is working, yes or no. Nope, not doing a thing. So I haven't gone anywhere except finding out that I need raspi-config every time. But oh, see, and now this is all quiet again. So data is high, clock is high, but data is 0. Let's see if this changes with. Look at this. It's all 0. it doesn't detect anything anymore. How is that possible? So, advanced options. I2C. Yes. Thank you. Yes, by default. Okay. Finish. And now even this doesn't recognize it anymore. What is going on? Do I need another reboot? And why would I need another reboot? This is not nice. Alright, end of this episode. Things are mixed. First of all, I need raspi-config to actually get the I2C working and the chip detected. Then, using using a map page, I find that I have to use certain settings. Then several attempts go to nothing. Adding an LED to check if this LED is working ends up with nothing. And next thing that happens is that the I2C chip isn't even detected anymore. So back to square one, despite raspi-config. Thank you for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up, leave a comment. You can also follow me on Twitter. Please retweet, like and leave a comment. You can also follow me on Instagram. Please like and leave a comment. Please donate to keep videos coming to you. You can also become a patron and have your name mentioned. More information on my website. And this is going to be continued. Thanks for watching.